intrinsic regulation of the circulation, peripheral circulation. So, generally, when you have small blood vessels that reaches all parts of the body, we need to control somehow how much of the blood flows through them. We have the intrinsic and extrinsic mechanisms. About extrinsic mechanisms we'll talk next time. About intrinsic mechanisms first. So first, what happens, for example, when not enough blood would get into the tissue? Yes. So we have some tissue. Let's say that this whole area is some tissue, and we have some blood vessel that goes through. The cells that are around, when they would have not enough oxygen, not enough glucose, and so on, will get signals to the vessel that they are starving for oxygen, for example, or for glucose, or for something else that is important for them. And they would send this signal, and it will lead to the situation that the blood vessel will dilate. So it became wider. Why? When the blood vessels becomes wider, it's lead to the situation that more blood can get through it. And when more blood get through, more oxygen would get and more glucose would get into the cells. So for example, when we have our hand, yes, and we will squeeze tight something, you know what would happen. First of all, it would get white, yes, as it is now. After some time, it may become even blue. But when you would unattach, unsqueeze, let it free one more time, it will become red. Why it is happening so? Generally, getting back to the picture before, when we would squeeze the vessel, we would block the flow through it. It will lead to the situation that all of those cells around would send the information to the bloodstream that they want more blood. Of course, these informations would be for vein, because there is no blood flow at the very beginning, so nothing can be done. But those metabolites, those information packages that gets from the cell would accumulate. So you would have a lot of these substances that are causing vasodilatation, that are causing increased blood flow in some area, to accumulate during time when there is no blood flow. So what would happen when we re-establish blood flow, when we unsqueeze the finger, for example? The vessels would become very, very wide. Yes? Of course, I'm exaggerating a bit, but they would get far bigger. And when they would get far bigger, far more blood would come to the finger, and the finger would get red. So this is one of the example of the local regulation. So what are the important substances that control this local regulation? One substance that you need to know is nitric oxide. Nitric oxide is extremely important for the local regulation of the blood flow, and it generally causes vasodilatation. So vasodilatation, one more time, is when the blood vessel gets wider. Vasoconstriction is when it gets more narrow. So, okay. The other example when the vasodilatation happens is, for example, during the training. So during training, we also need more of the blood that goes through. So there are more substances that will be released. For example, there's some prostacyclins, things like that. You read more about this on the presentation, or you already read. And it will lead to more of the flow through this area. But we have also sometimes the situations, local situations, that leads to the vasoconstriction. So the vasoconstriction is when we make the vessel smaller. Yes, when we contract the vessel. When it's beneficial. You already heard about something about blood clotting, yes? So the first phase of blood clotting is, maybe not of blood clotting, but first phase after the trauma to reduce bleeding is contraction of the vessel. So the vessel contracts and it leads to the situation that the blood flow is severely, through this area, is severely limited. This information is passed, for example, by the endothelium, but not only. So, generally you have some substances that can be produced locally that causes vasoconstriction or vasodilatation depending on the situation in this spot. Yes, so we're not talking anything about adrenaline, about the brain, about the nerves, and so on, because this is more general. We'll talk about this next time. But we have a lot of such situations that are very local, that are very on the spot, and that are very important for the control of the blood flow in some areas. Okay, thank you very much.